Good morning, Year 4. It's Thursday, the 11th of February. This is a math lesson for my group. We're just going to start by looking at the problem I left you last lesson. It says, how many acute and obtuse angles can you find in the diagram below? And I was hoping that you'd find quite a few. So let's have a look at starting to find the acute angles. Remember, acute angles are angles less than 90 degrees. So you're looking for something small. So if I lift my little shape up here, I can put my angle, little coloured angle in there. Can you see that I've made, there's an acute angle. Where else could I put this? I could put it there. Yeah. Where else could I put this? Oh, I could put it there. Yeah, another acute angle, and the opposite angle there is also acute. Yeah, and we could be thinking about the obtuse, those wide angles, and I'm going to show you that why from that line there, that line to there, all the way to there. And we see that that's an obtuse. It's bigger than 90 degrees. Now, if I turn this, you can see some other angles. I think some of you identified these really well. You can see that that's an obtuse angle. If I can just get that in there like that. Can you see from there, children? I've marked the obtuse angle there. Okay. And there are a lot of other obtuse angles. The other one that isn't mentioned, I wonder if anybody found a right angle. I was looking at this and thought, hasn't asked you for right angles, but I can put my angle measurer, my lovely little square, and it fits perfectly in there. And it fits perfectly in there. So I've got some right angles in here as well, and there. Okay. So that's what you had to do with that, and it asks you to label acute angles A and obtuse angles O. Well done with that little puzzle, boys and girls. So what are we going to do today? We're moving on from angles. We're going to look at triangles, and we're going to compare and classify triangles. Okay, and our in focus task is asking us how are they the same and how are they different. Now, I do apologise for the colour on this film today, but the sun is pouring through my kitchen window and it's a bit difficult to see. But these two here are red, this one is green and these are blue. You can just about see. And if you were comparing them or saying what they were like or how different, you might say, oh, well, some are red, some are blue, and there's one that's green. You might say some of them are larger, some of them are smaller. You might say, well, they're all the same because they've all got three sides and three angles. There's lots of different ways you can compare, and we're going to think about that today. Let's first of all think about the vocabulary that we're going to come across in this lesson, and some brilliant spelling for you today, boys and girls, and I'll be looking to see who can spell these correctly in their work over the next couple of days. We've got equilateral triangle, isosceles triangle, and scalene triangle. And we talked about triangle being three angles, yeah? Now, equilateral triangle, that looks a little bit like the word equal. So you should think about, what would that mean? What would that mean? Equal, equal, three angles. What does that mean? It means that all the angles are equal and all the sides are also equal as well. So the length of the sides and the size of the angles in an equilateral triangle. Now, my favourite, just because the spelling is so lovely, isosceles triangle. Okay, now an isosceles triangle has two angles and two sides the same and one side different. Okay, isosceles. And I always remember isosceles because it's got SOS there, SOS in the middle of this word. Okay, so you must make sure you've got those two S's there, isosceles triangle. And scalene triangle is the opposite of an equilateral triangle, remember? Equilateral, all the same. Well, the opposite of all the same is all different. So a scalene has all angles and all sides different. I've just put that information, whoops, there for you. Doesn't want to move. There for you, children. So equilateral, all sides and angles the same. Isosceles, two sides and angles are equal. Scalene, all sides and angles are different. And that's some of the vocabulary you're going to need today, and I might even ask you next time we do a little quiz or something. Okay, so this little girl looks at the lengths of the sides, and what you're going to need to do today is you're going to need to measure some of the lengths of the sides. So I'm really hoping you can get access to a little ruler or something at home. You know, and have a little. If you can't get access to a ruler, you could always use a piece of string and just measure the length of the sides of the triangles and mark it off that way, okay? But I'm hoping you've got access to a ruler or a tape measure. So this one, all three sides are equal, B and C. So she has measured them all. They go into this box because they are equilateral triangles. Only two sides are of equal length. So you can see this side here is equal to this side because they're the same length on that one. And on D, this side is equal to this side. So they are isosceles triangles. And quite a difficult one I always find to draw is this one, which is a scalene. All sides are different length. Okay, and that's how we can sort those triangles. This little girl decided to think about the perimeter to sort her triangles. So remember, we've come across perimeter before. Perimeter is all the way around a shape. Okay, so if you were to measure this length and this length and this length, can you see the arrows going round the shape? Okay, and if you were to measure this length and this length and this length, okay, you would find the two perimeters and you could work out if she was correct. But that is a way of sorting triangles. You might decide to think about, well, you know, have they got the same perimeter as each other? Okay, so in guided practice it says, in a scalene triangle, all three sides have different lengths. Which of these are scalene triangles? So here we've got our four shapes. And there's something you should do straight away because you are actually sorting triangles. And one of these shapes, you'll think, oh my goodness me, that's not even a triangle. It cannot be. Can you see which one is not a triangle, children? Yeah, this one at the end here. And if you can quite see it, I'll move it across a little bit. Can you see? That one is not a triangle. It's a quadrilateral. It's got four sides. So I'm looking at only these three shapes. Which of these are scalene? So I'd be getting my ruler and I'd be measuring to see which is scalene. How do I know which is scalene? Remember, all of their sides must be different for a scalene triangle. So F, this one, and H, this one, have every side is different. They are the scalene triangles on that one. In an equilateral triangle, all three sides have the same length. Which of these are equilateral triangles? Well, again, because we're working with triangles, which shape are you going to say? Let's just get rid of it straight away. I'm not even going to look at it because it's not a triangle. Yes, you're going to get rid of this shape, K. Yeah, K is a rhombus. Okay, it's not going to be a type of quadrilateral. We're moving on to those later in the week. So I'm only looking at this one, J, which you can't see because the sun is quite bright on there, boys and girls, sorry, L and C. Yeah, which of these are equilateral? So we're looking and we're going to measure with our ruler of each of these sides equal in these triangles here. Well, when I look at them, they look to be like that, but I'd have to measure them carefully. And actually, yes, J, L and C are equilateral triangles. In an isosceles triangle, two sides are of equal length, okay? Which of these are isosceles triangles? So using your eye, first of all, and then using a ruler, you will be working that out. You'll be thinking, right, which one looks as if it's got two sides the same? Well, I'm interested in N. Whoops, move that there, children, sorry. N looks like it's got this one long side here, but these two do look as if they might be equal. I'm also interested in M. M looks like those two sides could be equal. The others, I'm not sure. I'd have to measure to check that that one appears to be equilateral. They look the same. And that one I think is a scalene. Let's have a look. M and N. I was right. M and N are isosceles triangles. Okay, so this is possible to do on screen if you can't print, but if you can print it today, it's going to be much easier for you to do. But if you can't, you can still get your piece of string or your ruler and you can have a little go at measuring the sides and working out which triangle it belongs to. This is part of your task on Teams today. Okay. Remember, you can send me your task through Teams or you can email me. And I'm just quickly going to show you, children, just to remind you how to use a ruler and how to measure these carefully, because I don't think we've done this for a while. So here's my ruler if I was measuring this, remember? Lots of children like to put the edge of the triangle there, like that, with number 1. Remember, that doesn't happen. We've got to put it on 0 and line it up really carefully like that, and you can see that looks like it's 4.2 or just before, yeah, 4.2 centimetres. And then I would do the same with this side here. Okay, I would put my ruler on carefully, not at 1, put it on at 0 with that line measured to that line there, and you can see that is 5 centimetres. And then for the final side for this triangle, yep, that's 5 centimetres. So this one was 4.2 and these two sides here and here were 5 centimetres. What type of triangle is that? Two sides the same? Yep, you're right. It's an isosceles triangle. So just be careful when you're measuring that you really do. You can't measure wonky like that. You've got to get it really on the line. You've got to get your 0, which is this here, lined up to here, right to the corner, and you've got to get it really straight. Okay, like so. Okay, boys and girls, well, I hope you can try and find access to a tape measure or a ruler at home. As I say, if not, use a piece of string and then you can see which ones are the same and which ones are not just by marking it on the string. Okay, I'll see you next time. Goodbye.